When we find the inverse of a function, we verify that it's true by doing two things. The first is that we compose f with f inverse, and we should find that that simplifies to x. And the second is to do that in reverse, to take f inverse and compose it with f and find that that's equal to x. In this example, we have the function f and its inverse given, and we're going to algebraically verify that f composed with f inverse of x is equal to x. So to start, we'll start with that left-hand side, and then we'll algebraically simplify until we see that it equals x. So we'll take f and we'll compose that with f inverse. So we've got f of f inverse of x. And like any composition, we're going to start on the inside. So we have f of, and now we're given f inverse in this case, and it's given by 4x over the quantity 5 minus 3x. So we'll take f of, and then inside here we have 4x over that quantity 5 minus 3x. And now to simplify this, we're going to apply the function f. So f is defined by f of x equals 5x over the quantity 3x plus 4. So regardless of what we input, it'll follow that same pattern. So here, we'll have 5 in the numerator. We're going to have 5 times our input. And then in the denominator, we're going to have 3 times our input plus 4. And as we said before, our input here is that inverse function, which is 4x over 5 minus 3x. And that goes in each place. All right, now we're left with a complex fraction, and to simplify that, the easiest way will be to multiply that main numerator and denominator by the least common denominator of all those fractions with inside there. So looking, we can see that this 5 minus 3x is going to be that least common denominator. So we'll multiply the main numerator and main denominator each by 5 minus 3x. And what that'll do then is it'll essentially clear out all of those internal denominators. So it'll get rid of that complex fraction. So 5, put that original expression in, times our quantity, 4x over the quantity 5 minus 3x. And that denominator is still there. Okay. Now, as we look at this, it's important to note that we've multiplied the entire numerator and entire denominator by the quantity 5 minus 3x. So in the numerator, that will just cancel with the factor 5 minus 3x that we see, and we'll be left with 5 times 4x. But in the denominator, we have addition, so we're going to have to distribute across. So when it's applied to that first term, we're going to get 3 times 4x, and then it distributes. So we've got plus 4 times the quantity 5 minus 3x. At this point, we no longer have a complex fraction, so all we're going to do is simplify the numerator and denominator and combine like terms. So that numerator will be 20x, and that denominator will be 12x plus 20 minus 12x, which is then 20x over 20, which is, of course, just x. And so as we see, we started with f of f inverse of x, and we ended with x. So we've algebraically verified that when we compose f with its inverse, we get x.